Assalamualaikum warahmatullahi wabarakatuh. We are from Group D, which is consists of 4 members. My name is AFIQAH binti AZMI, Julia binti MOHAMED JAMRI, TUAN SYALIN binti TUAN SHAMSUL BAHARI, and SITI ALFIYAH binti RAHMAN. The title given for our group is Triple Integral in Spherical Coordinates for Vector Fields and Line Integrals. What is line integral? Line integral is a single integral over a curve in three-dimensional space that can be interpreted as the area under a curve in space. Important application of line integral is the computation of the work done as a variable force moved along an arbitrary path. The idea of line integral is to integrate over a curve. Second, to involve scalar fields or vector fields. Last is to solve problems involving fluid flow, forces, electricity, and magnetism. This is the example for application in engineering of line integral, which is to calculate the mass of a wire. Okay, the question is find the mass of a wire running along the plane curve C with the density rho xy equal to 3x plus 2y. The curve C is the line segment from point A 11 to point B 24. Okay, the solution is x minus xa over xb minus xa equal to y minus ya over yb minus ya equal to t. X minus 1 over 2 minus 1 equal to y minus 1 over 4 minus 1 equal to t. And we got x minus 1 over 1 equal to y minus 1 over 3 equal to t. Or we can write it in this form, which is x is equal to t plus 1 and y equal to 3t plus 1 prime. By using the formula m equal to integrate the limit from b to a rho x t y t times square root dx over dt to the power of 2 plus dy over dt to the power of 2 dt, and we put all the value based on this given formula and we will get 30 as a final answer. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Julia binti MOHAMED JAMRI and I will present and explain the example for triple integral in spherical coordinate for line integral. This is the example for triple integral in spherical coordinate. The example is evaluate the triple integral of tan xz plus 3 dv where E is the region portion of x squared plus y squared plus z squared equals 16 with z must be more and equal 0. This is the solution for the example. So for the first step is we must sketch the graph for equation x squared plus y squared plus z squared equals 16 with z must be more and equal 0, and then we get this graph. Second step is we must know the limit for pi, theta, and rho. For pi, the limit is from 0 to pi over 2. For theta is from 0 to pi. For rho is 0 to 4. And then we know that rho square equal x square plus y square plus z square. And x equal to rho sin pi cos theta. Y equal rho sin pi sin theta. And z equal to rho cos pi. And then we will substitute the value of x and z with the spherical coordinate given. So we will get 10 times rho sin pi cos theta times rho cos pi plus 3 and multiply with rho square sin pi d rho d theta d pi. We must multiply with rho square sin pi because this is spherical coordinate. So we must multiply multiply with suppose square sine pi. And then after that we will simplify all of this, and then we will get 10 whole power of 4 sine square pi cos theta plus 3 whole square sine pi d rho d theta d pi. And then we will integrate, towards d rho, and we get 2 whole power of 5 sine square pi cos theta plus rho cube sine pi, and limit of 0 to 4 d theta d pi. And then we will substitute the limit 0 to 4 into the row, and then we will get 2048 sine square pi cos theta plus 64 sine pi d theta d pi. And then we will integrate towards d theta, and we will get 2048 sine square pi cos sine theta plus 64 pi sine pi with limit 0 to 2 pi d pi. Then we will substitute the limit into theta, and we will get 128 pi sine pi d pi. After that we will integrate toward d pi, and we will get negative 128 pi cos pi with limit 0 to pi over 2. And then we will substitute the limit into the pi, and we will get the final answer is 128 pi. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good day. My name is Tuan SYALIN binti Tuan SHAMSUL BAHARI, metric number B0120101137. Today, I'm going to present to you the title of Triple Integral in Spherical Coordinates in Vector Field. Okay, what is meant by the vector field? Vector fields is the functions which the inputs are real number vectors and the output are also called vector fields. Vectors that contains 2 or 3 coordinates. To make these things easier to picture, I will explain to you what is the means by 2 or 3 coordinates. But vector fields also contain magnitude and directions. What is meant by directions? Direction fields is we want to see how the partial moving in particular vector fields. The basic formula, which is F is Rn equals to Rm, because vector field is a real number whether it's input or output. So, like I've mentioned just now, what is meant by 2 coordinates or 3 coordinates? Vector fields can work in any dimension, such as 2 coordinates is represented by x, y plane, and 3 coordinates is x, y, and z plane. We can find the applications or the uses of the vector fields in weather chart, gravitational force, electrostatic field, and magnetic field. These are one of the examples in weather chart. It means that what is meant by direction fields is direction fields as we want to find the moving of the partial. As you can see over here, the arrows in the white color is the partial moving, and it's called a direction field. So basically, what is the definitions of the real vector fields? As I've mentioned before, a vector field on 2 or 3 dimensional space is a function of df that assigned to each point, whether it's 2 coordinates or 3 coordinates. A vector field by given this formula equals to f xy equals to m xyi plus n xyj. This one is for the 2 coordinates. However, this one f xyz equals to m xyzi plus n xyzj plus p xyzk. These are the basic formula for vector field. Okay, these are one of the examples of vector fields that we can find it in GeoGebra, or we can do it in GeoGebra. As you can see, these are the partial of the vector fields when we define the x is equals to -2 and y is 1. So you can find it or you can try it at GeoGebra to obtain the result of the vector field to have a better understanding. As we can see here, these are the operations of vector function. Number one is product of scalar alpha and vector, which is alpha ft equals to alpha xypi plus alpha y1tj plus alpha z1tk. Second is a dot product, which is ft multiplied with gt equals to x1t x2t plus y1t plus y2t plus z1t z2t. And this one is the vector sum, which is ft plus gt equals to x1t plus x2ti plus y1t plus y2tj plus z1t plus z2tk. These are the two last formula for operation of vector function, which is you can use either closed product and also this product of a scalar function ft and a vector function, which is this one ft equals to ft xyti plus ft y1tj plus ft z1tk. As you can see, there's plenty of formula, but you have to use it wisely to solve your problems.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti BINTI RAHMAN and my matrix number is P0120100123. Today I want to present about triple integrals in spherical coordinate vector fields. Vector fields. Vector fields on R squared. Fxy equal to Fxyi plus Gxyj equal to Fi plus Gj. Vector fields on R3. Fxyz equal to Fxyzi plus Gxyzj plus Hxyzk equal to Fi plus Gj plus Hk. Divergence. If F equal to Fi plus Gj plus Hk is a vector field on R cubed and the partial derivatives of f, g, and h all exist, then the divergence of f is a function of three variables given by type f equal to del f divided by del x plus del g divided by del y plus del h divided by del z equal to del dot z dot f. Questions. Given the vector fields fxyz x cubed plus y cubed I plus y cubed plus z cubed j plus z cubed plus zk as z cubed plus x cubed k. A. Find the divergence of the vector of field F. Solution for A. Del dot F. In a bracket, del divided by del xi plus del divided by del yj plus del divided by del zk dot x cubed plus y cubed I plus y cubed plus z cubed j plus z cubed plus x cubed k equal to del divided by del x multiple x cubed by plus y cubed plus del divided by del y plus multiple y cubed plus z cubed plus del divided by del z multiple z cubed plus x cubed equal to 3x squared plus 3y cubed 3y squared plus 3z squared. So the final answer is 3 equal to, in a bracket, x squared plus y squared plus z squared. That's for me today. Thank you.